Hello and welcome back. Today we're going to take a look at the template method design pattern. This is a behavioral design pattern which allows you to define the structure of your algorithm within an abstract base class and allow for each of the subclasses to redefine certain steps within the algorithm. In our example today, we're going to be building a shipping calculator and want to create multiple calculators of various shipping methods such as ground and air, but have each of those individual calculators perform their own unique logic. We'll be creating our template class, which will contain the method calculate shipping rate. The calculate shipping rate method will then invoke the various abstract methods which have been overridden by the subtypes, and it's in these overridden methods that each individual unique piece of logic for the calculation of shipping will take place. So now that we're on the same page, we understand what the template pattern is, let's go ahead and get started. The first thing we're going to need to do today is actually go ahead and create our template class. So let's do class, we'll call this shipping calculator template. And we'll mark that as abstract. And now I actually want to create my template method itself. So let's go ahead and create my method called calculate shipping rate. And calculate shipping rate is going to need to take a few variables. So first, it's going to need zip code, because depending on zip code, maybe we'll want to provide some kind of surcharge. We want to give it the weight of the item, and then last, the size of the box that we're shipping. Now, size here is a simple class I created already, which will let me provide a height, width, and length in order to calculate the volume or the area that the box takes up on the truck, because they're going to charge more money, if this is a big box versus a little box. Now, the first thing I want to do is actually want to create a few of my template classes. So let's go ahead and create a method called determine weight multiplier. And this is going to take in the item weight. And let's go ahead and create another method that will determine our location surcharge. And then last but not least, we need to actually go ahead and create another method which will determine the multiplier based on the box size. Looks like I misspelled box size up here, so hold on real quick. And last but not least, I want to actually create the algorithm that will actually calculate the rate based on the various values, the multipliers and the surcharge and all that fun stuff. Now that I've gone ahead and created these properties, I need to fill out. So let's go ahead and just create weight multiplier is going to be an integer. We'll mark that as protected. We need to then do location surcharge, which is going to be a double. And then last but not least, I actually want to create my box multiplier, which is also going to be a double. Let's go and mark these as protected as well. Now what I want to do is actually fill out my abstract classes. So I've now created all my abstract classes, and for all intents and purposes, my template class, along with my template method, is complete. The only thing I need to do now is actually go ahead and create the various calculators. So let's go ahead and create a derived type off this, and we'll call this ground shipping calculator. We'll go ahead and implement all these members. Now, if this was a real application, there would be some kind of real business logic within all of this. But because this is this demo app, I actually have hard-coded some things such as how to determine the location surcharge, and if the weight, if it's over this limit, calculate as that, this, that, or the other. In order to save quite a bit of time, I'm going to go ahead and just copy and paste these in real quick. So I've now copied and pasted in my ground shipping calculator. And let's go ahead and take a look at what I've done real quick. What I've basically done is, just for testing purposes, created a list of various zip codes and various multipliers for location surcharge. If there's a weight, I've said, if it's less than 10 pounds, the multiplier is 1, less than 25, it's 2, else it's 3, and done a similar action for the box size based on the volume. So we can actually prove this with multiple shipping classes. I'm going to go ahead and paste in another one I have here, which is for air shipping. So I've created another one that's called air shipping calculator, and this does the exact same thing as the ground, but I've changed some of the multipliers. So let's actually see how this template pattern works in the field when I can actually create a test and create instances of the various calculators and see how they return values. Now I'm going to go ahead and create a unit test here that I've got stubbed out already called the ground shipping test. And what I want to do here is I want to create new instances of a ground shipping calculator as well as my air shipping calculator. And then what I'm going to do is actually call into the calculate shipping rate method on each one of these and see how the values come back differently. And we'll give this a zip code 90210. And we'll create a new size, and we'll say it's got a 5, 5, and 10. Let's go ahead and create one for air as well. And we'll leave everything here the same. Now, what I've done is I've created two instances of the two calculators, one the ground, one the air. And I've called the method calculate shipping rate on both of these objects, given the exact same values. Now, if everything's set up correctly, I'll actually be calling the calculate shipping method that is on my abstract class. Oh, looks like I misspelled something. There you go. It will actually run through and call the various abstract methods, which will then in turn call them on the subtypes class, so either ground or air, and then perform some calculations. So let's go ahead and run this and see what happens. So it's ran through, it's done my test, and I have a ground rate of 3 and an air rate of 4. Let's actually step back into this real quick and see how this works. So if I hit F5 here, you'll see it bounces into my template class, and if I continue on through, you'll now see it bounces over to my air shipping calculator. So we're going to hit F10 here, and we're going to step through this. And so it says my weight was greater than or less than 25, but greater than 10, so my multiplier is going to be 3. And then it's going to exit out, and it's just going to step through each of my various templates, and then finally comes back to my template class method, and we'll actually have all the values predefined, and I can return that back. So as you can see, when I step through this, it actually steps into my template, my abstract class, and then we'll step into the actual implementation classes for the various portions of the algorithm. So that in about 10 minutes is the template method pattern. This is a very useful pattern if you want to control flow and allow that all your subtypes change the actual implementation of your algorithm when you have very common functionality such as shipping or logging maybe would even be a good example. So hope you learned something. Until next time.